Kia ora. Yes, so I'm based in southern New Zealand at the Marine Studies Centre at the University of Otago. I might comment that it was 15 degrees when I left, so I'm loving this warm weather. I've been working with Jenny from the Centre of Science Communication, and we were interested in the impact of citizen science on student learning. So when developing citizen science projects, it's really important to consider who's driving the project and why. And we all know that a clear science question and robust data collection methods are key to engage the scientist. Addressing community concerns and highlighting local relevance is really important for engaging the local community. But is school-based citizen science something worth striving for? Opportunity to engage with lots of numbers and a diverse audience, but you've got the constrictions of the school curriculum and the school day. And when you're working with low tides, that's often a real barrier. But can we extend science education through citizen science and push beyond the scope of knowledge and skill development? So we developed the Marine Metre Squared project. This is a nationwide citizen science initiative for long-term monitoring of the New Zealand seashore. So it's about engaging schools and communities and families and iwi in getting to know their seashore neighbours. So basically putting down a metre squared area and counting and identifying the plants and animals found within. So we're collecting information about biodiversity, distribution, and abundance of marine species. And that baseline data, of course, will allow us to monitor change over time. Key to the project, though, is not just going out and collecting the data. We want them to do it more than once, but we also want them to upload the data to a national database. And we want them to learn how to interpret and analyze the results. We want schools and communities to start to develop their own questions and develop further studies that lead to ultimately improve coastal management. So the response from the schools has been really positive. They're going to the shore anyway. This has given them some structure of what they're doing. The teachers are getting professional development, really. They're improving their science skills and their confidence in doing science and the science process. It links really well with the school curriculum, particularly the nature of science. And students are getting experience in the science capabilities that are listed there. But we were interested in whether they're using these science skills to participate as critical, informed, and responsible citizens. And this is a goal of the New Zealand science curriculum. We looked at this in a number of ways, specifically at the impact of interaction time. So to assess the impact of a one-day experience of doing the Marine Metre Squared survey on the shore and then going back to the classroom to upload and analyze the data, we surveyed the students before they went out, and then we surveyed them afterwards. So to correct for the survey instrument, the impact of the survey instrument, we had a slightly different two different surveys that were very similar but slightly different, and those that completed survey A at the beginning did survey B at the end, and vice versa. So what we found out, 70% of the students said they felt like they were acting like a scientist. And we asked them why they were counting the animals and plants, and you can see that the pre-results are blue and the post-results are in red. Almost half of them seemed to understand that they were collecting data on species and habitats. And after the experience, there was a significant increase in the number who realized they were collecting data on population size and change. But few of those students could actually relate that data to seashore health. We were interested if students could connect the science learning with environmental issues. So we asked them, why is it important to look after the ocean's animals and plants? Again, you can see blue is pre and red is post. And this is some preliminary data. And there was definitely an increase. 70% of the students felt there's a significant increase in the understanding of the value of looking after marine species to prevent population decline. And there was also an increase in understanding of animal rights. So after they'd been out on the shore, they were like, yes, these animals are alive, we need to look after them, they deserve to live. When we asked if the project encouraged environmental stewardship, so describe things that you and your community could do to look after the shoreline, as you expect, rubbish topped the list. And the other significant increase was care for wildlife. And that really came about because when we were on the shore, we were saying, look after the species, turn the rocks back, put the animals back where you found them. So that obviously got through to some of the students. But we wondered whether the Marine Metre Squared project could be extended to develop these citizen science, citizenship capabilities. The Sediments and Seashores project gave us an opportunity to answer this question and look at whether citizen science could drive civic engagement. This project looked at how increased dredging affected the Rocky Shore community. So this was a community-driven project, and it was about the community, and scientists were concerned that the Port Authority gain consent to deepen the shipping channel. And there was little information available about what increased sedimentation, what impact that would have on the animals and plants in the harbor. So there's quite a lot of both scientific and community concern. And that gave the students a real reason to do the surveys. And to collect relevant data, we needed to extend the sampling time and increase the training. So we ended up having 6 sessions with each school. We involved 8 primary schools and 2 secondary, and those sessions were run over a 4 to 6 month period. And the students were involved in the full process, right from developing the research question through to reporting back to the Port Authority. So we went into the classroom, we talked to them about the issue, the dredging that was happening, what impact it might have on the marine animals. And then they came up with their own research plan. So they decided on what the research question was. They decided on where they were going to sample, what sort of information they were going to collect, what equipment they needed, who they should consult with, who they might report to, when they should go out, so looking at low tide times. And they even looked at how they could keep themselves safe. So they did a full research plan. When they went out to do the data collection the first time, they knew they had a clear purpose, they knew what they were doing, they needed quite a lot of help with species identification, but that was something that developed over time. We went back to the classroom, they inputted their data on the database, they analyzed it, they graphed it, they did blog posts. They had a second data collection a few months later, and then back to the classroom again for data analysis. And this time they were able to compare their data with the first data collection. They came up with a sensitivity index, so to look at which species would be more vulnerable to sedimentation. And then we took the data away. The scientists crunched the data and summarized it for their site and compared it to other sites around the harbor. We went back to the classroom, presented the data back to them, and had a really good discussion. And from that stage, then the class developed their own presentation that they gave to a community day, which included the Port Authority, the scientists, the community, and the other schools. So it was very positive. And many schools extended the work in the classroom. The secondary schools went on and did science fair projects. We surveyed the students before the experience, and we surveyed them again at the end, because in addition to the science, we were interested in the impact on the student learning. And certainly it did have an impact. For example, when we asked the secondary students, how confident are you in designing and carrying out a science investigation, there was a significant increase. But when we asked them if they were able to connect their science learning with current environmental issues, there was less of a change. So does that mean they're not able to connect their science learning with the environmental issues? Or was the question too general? Did we need to rephrase the question? So we rephrased it for primary students and tried to relate it more to the actual experience. So to assess the understanding of environmental issues, we asked them, what challenge does the crab on the intertidal face? And it was interesting to compare the pre and post results. The don't know and no answer you can see went from 34% pre to about 4% afterwards. So afterwards they were much more able to give a response. And although initially they thought predators, people, and pollution were the challenges, after this extended experience, they identified population decline, finding food, habitat loss, as well as factors relating to sediment as being challenges. So then we wanted to compare the one-day experience versus the extended experience. So the pink is the post-survey from the one-day experience, and the dark red is the post-survey from the extended experience. And you can see that when we asked them why it's important to look after the animals and plants, after the one-day experience, they were concerned with individual species, population decline, and animal rights. But after the extended experience, they related the importance of the ocean to survival of the planet and for our survival. Also, we were interested in action for the environment, comparing the post results for the one day and the extended experience. And although reducing rubbish topped both, you can see after the extended experience they were able to give a much wider range of things that they could do to help the environment. And some of them were quite general, predicting habitats, caring for wildlife, but others were more specific: regulate fishing, educate and lead by example, survey populations, regulate dredging. So in summary, short-term engagement, students were certainly able to develop some science skills and capabilities, but they weren't able to apply the knowledge to environmental issues. In terms of the long-term engagement, and remember that I've only presented some of the results from these surveys here, having a clear why certainly increased their motivation. Development of science skills and capabilities certainly improved the data collection. Increased connection with the environment, so the more time they spent out there, increased their knowledge and understanding. And understanding and awareness of the issues, the environmental issues, certainly led to better ideas for environmental action. So can citizen science drive more than student learning? Yes, it can. The duration of the engagement certainly is important, and I think when working with children, the framing of the question also plays a role. So again, thanks. We have lots